Dear participants, welcome. Now, this is another session. Today, we may discuss about the confirmatory fact analysis, especially the interpretation. How can the researcher interpret different tables related with the confirmatory fact analysis? We have already conducted EFA, CFA, and structural equation modeling, but we did not yet discuss about different tables related with the confirmatory fact analysis. We have obtained different table. Then today I want to discuss about the different table related with the CFA. This is the interpretation of confirmatory fact analysis. Okay, I may share the output screen to you. At the end of the confirmatory fact analysis, you should get a picture. In that platform, there is a menu that is known as view test. Whenever you click on view test, you will get the output. I may repeat the procedure again. Please do the CFA. Please draw the CFA picture. Please draw the CFA figure. On your left-hand side, there is a menu platform. In that menu platform, there is a box. That box is named as view test. Please click on it, then you will get the output. Now I may share my Amos CFA output screen to you. Okay, wait. Share. Okay, this is the output. This is the output screen, CFA, Amos output screen. We have already identified 5 construct, 5 factors. Okay, this is the most important. Okay, on left hand side, you can see so many menus. Analysis, summary, notes for group, variable, summary, parameter, summary, etc. The most important one, model fit. Please click on it. Model fit. Okay. Then model fit. Please click on model fit. Then you can see the different items related with the model fit. Okay. Then model fit means model fit indices related with the confirmatory fact analysis. The first one, absolute fit indices. Absolute fit indices. That is the first one. You can see a chi-square value here. Chi-square value. Yeah, chi-square value. Also, you can see degree of freedom. You can see the p-value. You can see the chi-square value divided by degree of freedom. Actually, in case of one-way ANOVA, if the p-value is less than 0.05, you can reject the null hypothesis. That is the result. Likewise, if the chi-square divided by degree of freedom is less than 3, then it is a good model, good confirmatory fact analysis model. That's interpretation. If the chi-square divided by degree of freedom is less than 5, no problem, it is acceptable. It's not good, but it is acceptable. That is interpretation. In our table, you can see chi-square value, that is CMIN, that is 1178.105. Degree of freedom 265. P-value good. If the p-value is less than 0.05, then it is good. It is desired good. Here 0.000. Then in CFA, there is no hypothesis. All hypotheses are related with the structural equation modeling. You can see the chi-square value divided by degree of freedom. That is less than 5. Then fit is acceptable. Confirmatory fact analysis is acceptable. In at the end of the EFA, we have got 5 construct or 5 factors. Those 5 factors are correct or incorrect. To test the correctness or validity accept of those factors, we have conducted the confirmatory fact analysis. Yes, as per a chi-square value divided by degree of freedom value, yes, those 5 factors are valid, acceptable. We may proceed with the structural equation modeling. That is interpretation. Okay. Then next important value, absolute first heading, absolute fit indices. In absolute fit indices, you have to note chi-square value, chi-square divided by degree of freedom, then p-value. The next absolute fit indices, absolute, what is meant by absolute fit indices? Absolute fit indices means these show how well the model reproduces the observed data without comparison to another model. Then at the end of the article or in your thesis, you have to write absolute fit indices. Then you have to show chi-square value, chi-square divided by degree of freedom. The next value under the absolute fit indices, that is GFI. You can see a GFI value. The GFI means goodness, good, GWD, goodness of fit index. That is known as GFI. Here you can see the GFI value is 0.812. The standard value, if the value is greater than 0.90, it is good. If the value is equal to or greater than 0.95, it is excellent. No problem. Our value is near 0.9, then value is good. GFI value is good. Another absolute fit index is AGFI, that is known as adjusted goodness of fit index. Standard value, if it is equal to greater than 0.90, good. Our value is about 0.8, no problem. It is near 0.9, then it is good. The most important value as related with the confirmatory function analysis, the chi-square by degree of freedom. On the basis of chi-square divided by degree of freedom, researcher can accept or reject the CF analysis. If the chi-square divided by degree of freedom is equal to 25, our CFA model is not valid, then we cannot proceed with the structural modeling. Then the researcher have to rethink about the theory, EFA, CFA, etc. If the chi-square value divided by degree of freedom is 28, the researcher cannot proceed with the sum. Researcher has to stop the entire process. Now, she cannot proceed with the structural modeling, but we can no problem, we can proceed. We have the value, the chi-squared value divided by degree of freedom is 4.446. That is the acceptable value. We can proceed with the structural modeling. Actually, we have conducted a structural modeling, no problem. It is correct. Then next index, it is incremental fit indices. Incremental fit indices, that is the next heading. These compare the proposed model to a baseline model. You have to note the default model values. You need not notice about the other values. You have to only think about the default model values. Then incremental fit indices. Under incremental fit indices, first one CFI. You can see CFI value here. CFI is known as comparative fit index. Here standard norm, if it is equal to 0.9 or greater than 0.9, it is acceptable. Yes. We have got a value 0.910. It is acceptable value. Then our CFI value is valid. No problem with the CFI value. Next incremental fit index, that is a TLI. You can see the TLI value there. TLI means the Tucker-Lewis index. TLI. Here TLI value is, we have got about 0.9. If the value is greater than or equal to 0.9, it is acceptable. That is the standard norm. Yes, our value is acceptable. Next incremental fit index is NFI. That is normed fit index. NFI value is about 0.9. Then what is the standard norm? If it is equal to greater than 0.9, it is acceptable. Yes, our value is acceptable. Next fit index, that is known as parsimony fit indexes. Under the parsimony fit indexes, the most important values are first one PNFI. That is parsimony NFI. Parsimony NFI, that is known as PNFI. What is meant by parsimony fit indices? This balance model, fit and simplicity. This balance model, fit and simplicity. PNFI value, standard norm, if it is greater than 0.5, it is acceptable. We have got a PNFI value is 0.789, then good. The value is acceptable, good value. Next, PGFI, you can see a PGFI value there. PGFI, PNFI value, okay. PNFI value 0.783, then PGFI, that is parsimony GFI. But unfortunately, we have not got the PGFI, no problem. You did not write about it. The just value, just important value, that is known as, please wait. You can see RMSCA, that is a next value, next important model fit index value, that is RMSCA, that is root mean square error of approximation, that is RMSCA value. If the RMSCA value standard norm less than or equal to 0.08, value is S is equal to 0.08, it is good. Our RMSCA value is not 0.089. RMSCA value is 0.095. So a slight increase over the standard norm value, no problem. It is we will take it, no problem. RMSCA value, okay. Standard value is equal to or less than 0.08. I will repeat again. In case of RMSCA value, standard value is equal to or less than 0.08. But unfortunately, we have got a value that is 0.095. No problem. It is still acceptable. This is the interpretation related with the model fit indexes. Most important one is the model fit indexes. In the model fit index value, most important one is the chi-square value divided by degree of freedom. If the chi-square value divided by degree of freedom is less than 5, no problem. The model is good and acceptable. It is not excellent. If the chi-square value divided by degree of freedom is less than 3, then it is excellent. But our model is not excellent. Still, it is good and acceptable. That's the interpretation. The next, there are so many tables in the CFA interpretation. CFA output, you can see so many tables. The next one, assessment of normality. As we know, EFA, CFA, and structural equation modeling are related with the normal distribution. If your distribution do not follow the normal distribution, you cannot conduct with the EFA, CFA, and structural equation modeling. That means next type of interpretation is related with the normality. That means you have to note two values. First value, skewness value. Second value, kurtosis value. If the skewness value and kurtosis value are good, you can assume that the distribution follows normal distribution. If the distribution follows normal distribution, you can conduct EFA, CFA, and structural equation modeling. That is the next interpretation. Actually, there are three types of skewness: positive skewness, negative skewness, and zero skewness. Okay. Then what is the standard value? As far as skewness is concerned, if the value lies between -1 and +1, no, it is good, no problem. It is excellent. It is excellent if the value lies between -1 and +1, it is excellent. If the value lies between -2 and +2, okay, no problem. That approximately normal. All we have got so many skewness values there. Very good. All values lies between, I think, -1 and +1. In case of skewness, then it is excellent value as far as skewness is concerned. Then next one, kurtosis value. Okay. On the basis of skewness and kurtosis, we can write distribution follows normal distribution or not. Okay. In case of kurtosis also, three type of kurtosis, that is normal distribution, then platykurtic and leptokurtic. Then what is the standard value? If the value lies between -2 and +2, okay, it is acceptable. That data approximately normal. That is the interpretation. Here all values lies between -2 and +2. Okay, data follows normal distribution on the basis of skewness and on the basis of kurtosis. You can write that distribution follows normal distribution. No problem. Then CFA model is good. Why? Chi-square distribution value based on the chi-square divided by degree of freedom. Our CFA model is good. 5 factors construct are valid. There are so many tables you have to interpret. Yes, we may continue the interpretation of CFA on tomorrow. Okay, goodbye. I am your course coordinator and course instructor, Dr. Shivakumar, FCMA. Okay, thank you.